Assalamualaikum and hi, my name is Nur Bashira binti Adukapur.
My name is Syafiqah Edina binti Zulkifli.
My name is Nur Ajak Clementi Idris. My name is Nur Ain binti Abdul Aziz. My name is Aidan Azika binti Azimi. We are will present about mechanical materials.
Okay, so now is introduction of mechanical materials. So the practical of application of engineering materials in manufacturing engineering depends upon true knowledge of their particular properties under a wide range of consider. So the term of property in qualitative and quantitative measure of response of materials to internal exposed conditions like force and temperature of materials mechanical. However, the range of property found in different classes materials is very large.
Hi, so I'm gonna explain about classification of material property. They have 4 types of material properties, which is chemical, physical, mechanical, and dimensional. So I'm gonna explain about mechanical. Types of mechanical is strength, tension, and compressions. Next, mechanical is tautness and stiffness. Then mechanical is elasticity and plasticity. Other than that, mechanical also ductility, brittleness, and hardness.
Okay, now I will talk about mechanical properties. The properties of material that determine its behavior under applied force are known as mechanical properties. They are usually related to the elastic and plastic behavior of the material. These properties are expressed as function of stress strain. A sound knowledge of mechanical properties of materials provide the basis of predicting behavior of materials under different load conditions and designing the component out of them. Thank you.
Okay, next I will explain about stress and strain. Experience show that any material subject to a load may either deform, yield, or break depending upon the first, the magnitude of load, second, nature of material, third is cross-sectional time. Okay, next I will look to the sum total of all the elementary intraatomic forces or internal resistance which is the material is called upon to exert to contract the applied load is called stress. Okay, mathematically the stress is expressed as force divided by cross-sectional area. Next is strain. Strain is the dimensional response given by material against mechanical loading, deformation produced per unit length. Mathematically, strain is change in length divided by original length.
Now I will explain about the strength. The strength of a material is capacity to withstand destruction under the action external loads. It determines the ability of a material to withstand stress without failure. The maximum stress that a material will withstand before destruction is called ultimate strength.
So next is elasticity. So elasticity is the property of material by virtue of which deformation caused by applied load disappear upon removal of load. So elasticity is also a material is the power of coming back to the original position after deformation when the stress or load is removed.
I will explain about plasticity. The plasticity of material is its ability to undergo some degree of permanent deformation without rupture or failure. Plastic deformation will take only after the elastic limit is exceeded. It increases with increase in temperature.
I will explain about stiffness. The resistance of a material to elastic deformation or deflection is called stiffness or rigidity. A material which suffers slight deformation under load has a high degree of stiffness or rigidity. For example, steel beam is more stiffer or more rigid than aluminium beam.
Next is ductility. It is the property of material which enables it to draw out into thin wires. Example, mid steel is a ductile material. The percentage elongation and the reduction in area is tension is often used as empirical measure of ductility.
Next is I will explain about malleability. Malleability of a material, it is ability to be flattened into thin sheets without cracking by hot or cold working. Example, lead can be readily rolled and hammered into thin sheets but can be drawn into wire.
So, just now my friend already explained about ductility and mobility. So, now I'm going to explain about comparison of ductility and mobility. Ductility and mobility are frequently used interchangeable many times, and also ductility is tensile quality while mobility is compressive quality.
For resilience, resilience is the capacity of a material to absorb an energy elastically. The maximum energy which can be stored in a body up to elastic limit is called of proof resilience, and the proof resilience per unit volume is called modulus of resilience. The quantity gives capacity of the material to bear shocks and vibrations.
Next, I will explain about hardness. Hardness is a fundamental property which is closely related to strength. Hardness is usually defined in terms of the ability of a material to resist to stretching, abrasion, cutting, indentation, or penetration. Methods used for determining hardness is Brinell, Rockwell, and Vickers.
Next, I would like to explain about brittleness. It is the property of breaking without much permanent distortion. Non-ductile material is considered to be brittle material. Example is glass, cast iron, and others.
Next, I will explain about creep, the slow and progressive deformation of a material with time at constant stress is called creep. Depending on temperature, stress even below the elastic limit can cause some permanent deformation. It is most generally defined as time-dependent strain occurring under the stress.
So next is fatigue. This phenomenon leads to fracture under the repeated or fluctuating stress. Fatigue also fracture are progressive, beginning as mini cracks and grows under the action of fluctuation stress. Other than that, many components of high-speed area, his turbine engines are of his type. So next is many components are high-speed Euro and turbine engines of are of this type.